in this activity, we are going to continue to look at the spread of data. We've got two sets of test scores for a couple of students in the same math class, and we're going to compare the mean of their scores and the standard deviations of their scores. Some of you have done a little bit of work with standard deviation in Algebra 2. Remember, in general, it's just a measure of how spread out our data is. We kind of get a sense about the average distance every point is away from our mean. We are going to begin analyzing our data by making a dot plot. In our dot plot, notice that Jonas's scores are marked in red and Sal's scores are marked in purple. Without calculating, we want to describe which of the students' scores has a higher standard deviation. Remember our standard deviation, we're looking at how far apart our data is spread. And so if we compare the two sets of data, notice that Jonas has data that is more spread out. So we would think that his data, without calculating anything, has the highest standard deviation. The next thing we're going to do is actually calculate the means and the standard deviations for both students. While we could do these things by hand, we are going to use our technology to calculate them. I'm going to create a Google Sheet, which you can also do along with me to make sure you get the same answers. And we're going to find the mean of both Jonas's and Sal's test scores, as well as the standard deviation of each. And so you can do this also in Excel. You can do this using a graphing calculator, but we're going to use a Google Sheet. So we'll begin by entering both of their scores. I'm going to make a column for Jonas and I'm going to make a column for Sal's scores. We'll put each of their scores into our sheet. So remember, if we were calculating this mean by hand, we'd have to add those scores up and divide by 4. Since there are 4 scores for each student, to do this on our sheet, we're going to use a formula. And so we're going to do equals, and we want the average. Although it came up, I'm going to go ahead and type that in there. And we want the average of our 4 scores. And so if yours doesn't come up with a suggestion, we can highlight those numbers and press enter. And so our mean score for Jonas is 93. We're also going to calculate the mean score for Sal the same way. I'm going to go ahead and use my suggestion there and push enter. Notice they actually have the same mean score. So we're going to look at our standard deviation. We can also do that using our Google Sheet. This time when we put our formula in, we'll do equals and STDEV for standard deviation, and we're using that same set of data, and we push enter. Notice Jonas's standard deviation is about 6.83. We're also going to do the same for Sal, and his standard deviation is much less at about 2.16. And so we want to talk about what that means. Notice the students have the same mean, but their standard deviations are different. If we take a look at Jonas's scores, they're not really all that close together. He has some very different scores with each test, but with Sal, most of his scores are very close together. He's much more consistent in the way that he scores. Our final question in this first section adds in another student. The student's test average is 87 with a standard deviation of 0. Well, if our standard deviation is 0, those scores aren't moving away from our mean, which means that all of the scores must be 87. Now I'm going to have you give it a try. We've got 5 sets of data here, all which have the same mean. The first thing I'd like to have you do is to calculate the mean. I know some of you went straight to your Google Sheets and started finding that mean, but if you take a look at set B, notice all of your data is the same. And so if we were to add those numbers up and divide by how many there are, we would still get that same number. So our mean for each of our data sets is 7. The next thing you're going to do is put your data in order from that which has the lowest range to the set that has the highest range. Remember, your range is just how far apart your data is spread, and so we're going to subtract the maximum value from the minimum, or the minimum value from the maximum value. Notice that our smallest range was in data set B, followed by data set C, and then D, and A and E have the same range. We're now going to take a look at the standard deviation, and we're going to do the same thing. We're going to put our data sets in order from lower standard deviation to higher standard deviation. First, try to determine what that looks like without doing any calculations. Here's a quick dot plot of our data. Do you think that the order that these will go in is going to be the same as our range from least to greatest? Let's go ahead and actually calculate our standard deviations and see if what you found in your box plot is the same thing that you find when you find the actual standard deviation values. And so here we have our actual standard deviations. Notice our data with the least standard deviation is set B, followed this time by set D, then set A, and C, and finally F. Remember, at the beginning, our ranges of, my fault, that was set E. The ranges of set A and set E were the same, but their standard deviations are a little different. So our lists for our range and our standard deviation are similar to each other, but they are not the same. Our range looks at our data from minimum to maximum, and it doesn't matter how close those data points are together in between. Whereas our standard deviation, those things matter. For example, if we look at D, which has a higher range than C, most of D's data is clumped together on one side, and C's data has a clump on the left and a clump on the right, and so the data is more spread from the mean.